Hi there. I am going to be demoing my TD Bank chatbot. This is a multi-agent system made with the CrewAI framework and has short-term or long-term memory available. I will go through the code and talk about the features, then demo how an actual conversation would look while explaining how CrewAI works. After importing the packages and getting API keys from .env file, I load in the base English model for Whisper AI. This will be important for my speech-to-text feature later. This memory type variable allows to choose whether the chatbot is going to work with long-term memory or short-term memory. I will set it to long-term memory for now. This is the main logic of my chatbot, and here I get the input. If the user types in the string voice, it will lead them to the voice-to-text function. This function uses FFmpeg to record the message in the terminal and Whisper AI to transcribe it. Because FFmpeg has different recording commands for different operating systems, I use platform.system to check which operating system they are using. After recording, the message is transcribed, the results are printed, and then returned to the run function. After the input has been given, it is passed to my guardrail agent, who will analyze if the user prompt is relevant. This agent is also given the last 6 messages in the conversation for context. For example, if the chatbot outputs a report with several points and the user asks to talk specifically about the second point, the string talk about the second point is not relevant to TD and finance, but when given context about the conversation, it is relevant. This agent also rephrases the prompt so it's easier for my crew to understand. The guardrail agent would either output yes or no, which allows me to tell if the prompt is relevant or not. If no, then a hard-coded message will be given out asking the user for clarification and a new response. Going back to the main logic, I will now be explaining the logic for long-term memory. I will first find the 2 most semantically similar memories to the user prompt from the mem0 database from both the user and the chatbot. So in total, I will be grabbing 4 memories. I then pass both the memories and the user prompt to the crew and launch it. After the response has been given, I add both the user prompt and the chatbot response to the mem0 database in this function. In this function, I use threading to add the memories because there can be a delay, and I do not want to stop the main flow. I will now be explaining the short-term memory of my chatbot. I do not pass any memories from mem0, and I instead pass the conversation history to the crew. After every exchange between the chatbot and the user, I add the exchange to the history array. I also ensure that I only pass the last 8 messages of the conversation to my crew to prevent a lack of efficiency due to having too much information to process. I will now move on to the demo of my code for the long-term memory. I will be asking a question about auto loans. As you can see, I have passed 4 memories to the financial researcher. Its job is to research information about the user's prompt. Memory 1 and 2 help give the researcher agent context about TD's auto loans, while memory 3 and 4 give context that the user is interested in interest rates and wants specific details about different options and features. This helps give personalization as well as higher quality answers. Taking these memories into account, the agent will then research using the SerperDev tool for the top 2 websites relating to the user's prompt. I have limited my research to only the first 2 websites that come up to ensure accuracy. After researching, it will then pass the information to the next agent. This summarizer agent is in charge of taking the research and putting it into a good summary for the user. It also has access to the 4 memories to help with its output. Once the summarizer agent is finished, it passes the information to the last agent. This agent is the CrewAI agent who ensures the summary does not break any TD policies and does not disclose any private information. Once the QA agent has approved the summary, it will then output it to the user. I will now ask a follow-up question about the average price of these loans. As you can see, the memories given to the researcher agent are different, as it even talks about the percentages and prices. It will then go through the same process with the financial researcher, getting information about auto loans from TD websites, and passing the said information to the summarizer agent. The summarizer agent will take the information and make the summary, then pass it to the QA agent. Once the final summary has been approved, you can see that it has been outputted to the user. I will now be moving on to demo the short-term memory. After changing the memory type variable, I will rerun the code. So now, when looking at the information the researcher agent has been given, it does not have the memories from Mem0. Instead, it will hold the short-term history of the conversation over time. It will now go through the same process as usual with the three agents and give an output. I will now give a second input to show how the short-term memory works. You can now see that the researcher agent has my first prompt and the output from my first question. It will use this information for its research and its response. After going through the same process, the final output was given. This output took a very long time to be given due to its length. I will now put this into a markdown converter to show how it would look. So this concludes the example of the short-term memory. I will now be demonstrating a quick example of the speech-to-text. By typing the string voice, it connects to the default microphone of your computer and starts recording for 6 seconds. After the recording and transcribing, you will be given the output of what was transcribed. The message is then passed to the guardrail agent. After, the crew will respond as if it were a normal input. I will now give an example of what happens when an invalid prompt is given. As you can see, the chatbot refuses to answer and replies with this hard-coded message. This is the crew file where you configure the structure of your crew. I gave the researcher agent access to the SERPer dev tool in this file, and I have specified its results to be in Toronto. I also configured the other parameters for each agent in this file, as well as the tasks and the general information about the crew. This is my agent's file where I gave information and specific details for each agent, such as their role and backstory. This is the task file, and you can see how the research task, reporting task, and QA support task were written. So that concludes my demo video, where I showed the logic behind my TD chatbot, its features, including the proof of concept speech-to-text feature, its guardrails, and the short-term and long-term memory. I hope this helped explain how my chatbot works. Thank you for listening.